Hi everyone, welcome back to my channel. So this video is coming after a long time, and in this video we are continuing the LLD series only. In this video we are going to learn about the template method, okay, which is also a behavioral design pattern. And in this video we will see the theory of the template method and its pros and cons, how we can implement this, and the theoretical part we will cover all of that in this video only. In the upcoming video, we will try to implement that into the Java, and we will see the best practices that you can do with the template method. And also, we will see multiple examples for template method where we can use the template method. So without further ado, let's get start into this video. Now let's start with this template method pattern. Okay. So in this template method pattern, we are going to take an example of file parser, okay, or data parser. What we have, we will have a data parser, and in the every data parser, what we can do, we need to parse that, we need to validate, we need to extract some information, and we need to transform that information, and then we need to save that. Okay, these are the common steps that CSV parser, JSON parser will have, or XML parser will have. Okay, so we'll see how we can write this problem into a very good way. So the problem is every parser follows the same process. Okay, see, without a pattern, common workflow gets duplicated. Okay, if I am writing a JSON parser, I will do reading of that file, validating that file, extracting, transform, and save. Now, the next day, I have to write that CSV parser. So what I will do, I will copy or I will rewrite that same steps again in the CSV parser. Okay. So these is where the problem starts. Okay. And next day, let's say we have to write a XML parser. Then we need to copy paste all the steps again into the next file as well. Okay. So that is not the correct way to do it. Okay. So there are some pain points. So duplicate workflow code and to harder to change the sequence, and more classes can drift apart. Let's say now I'm reading a file from a directory, and next day I have to download that file from the some cloud, or I maybe get that file from anywhere, correct? Then I need to change that read file step into all these parsers. Would be a great choice? No, correct? So for this, we are having this template method. So let's see what template method does. So move the invariant algorithm into one base class. What does that mean? Means if we are having common steps into these between these parsers, then we can extract those steps and we can make a data parser abstract class, and that will have the all the common steps or the algorithm base algorithm skeleton of that parsers. Okay, that needs to be changed by these parsers. They can implement those things by their own. Okay, so that is the idea behind it. Means same algorithm but different implementations. So that is the core idea of template method. I hope you got it, guys. So this is the UML style view. Okay, you can see we are having this data parser abstract class. Okay, so this is having a final parse method. Okay, and it is also having these methods like reading the file, validating, extracting, transforming, save. Okay, these steps vary on this JSON parser. It will have the extract method different, transform method would be different. Okay, validating method would be different for JSON parser and CSV parser, correct? So this is the implementation of this data parser class. Okay, so now we are having this abstract class data parser. Okay, in this we are having a parse method which will call all these methods. Okay, it will read that file, validate, extract, transform, and save. These are the common steps, and that needs to be done in every parser. So now we are having some common functionality like validating this file and saving that file. That would be same for all of these parsers. We are assuming that if that is not the case, then we can also make this as abstract. child class will take care of this as well. But we are assuming that validating and saving the part is same for all the parsers. But in the reading that file, extracting that file, and transforming that file will directly depend on the parsers that will implement or extend this data parser abstract class. Okay. So they need to implement these methods, and otherwise, uh, and other methods are written over here only. So that will be used here in the parse method. So now let's take an example of JSON parser implementation. So JSON customizes the steps that are format specific. Let's say the reading of that file would be this method they need to implement, because that is an abstract method, and a similar way in the extracting and the transforming. So these steps are dependent on this JSON parser like the child class. Okay, and it will inherit that parse method and the validate and save method that are written in the parent class in the data parser. In same way, in the CSV parser, it will read in its own way, extract its own in own way, and transform the data in its own way. Okay, and it will inherit that parse and the validate and save method. Okay. Now, what will actually happen when we will run that code? Now, let's take an example of we are creating a parser of type data parser and the object of JSON parser. Okay, at the runtime, it will take all the methods that are written by this JSON parser. So this is the runtime polymorphism here. Okay, if we will call that parser.parse, then read method is defined in the JSON parser will be called. Okay, validate method in the JSON parser will be called, and this save method will be called in the data parser because the parent class is having this implementation. Okay. Similar way, if we change this object to CSV parser, then CSV parsers functions will be called. Okay. So at the runtime, it will decide which method it need to call. Now, let's see why this is so powerful. So the order of these steps would be guaranteed. Okay. It is not dependent on the child class. Okay. It is defined in the parent class. So it would be a similar for order. Okay. Client does not know internal things. Okay, the common steps are reusable, and if let's say we want to add a new parser, okay, then we can simply use and extend that data parser. So that would be a easy step. So now let's add a new XML parser. So here what we are doing, we are just extending the data parser, and we are implementing these read, extract, and transform method by its own. Okay, so that is very easy to implement the XML parser. If we don't have this data parser, then we need to implement all the method in the same order, and we may make some mistakes while writing the same code again and again. Okay, so that is the advantage over here. Now let's differentiate between the template method and the ordinary inheritance. So in the ordinary inheritance, what it is doing, it just provide the reusable code only. But in the template method, it can change only the abstract methods only. Okay, so that are the like they are having a limited control on the steps. They can't change the order of that parse method. Okay, so there is sequence is enforced. There is no guaranteed sequence, and the reuse is the main idea behind the inheritance, and the controlled variation is the main idea behind the template method. Think in a perspective like same algorithm, but we have different steps at sometimes. Okay, so that is the idea behind it. Now we are having the advantages over here. So reusable common workflows, and the order is controlled, easy extensions, and shared behavior across all the things. In the interview, they may ask like, what is the template method? You can simply say like defines the skeleton of an algorithm in a base class, and it keeps the sequence fixed while subclass customize their specific steps. Okay, and often uses the abstract methods and the hook methods. So great for the JSON, CSV, XML style parsers with a shared workflow. So yeah, that is all about the template method. And in the next video, we will implement the template method by our own. So I hope you guys loved this video, and if you did, then hit a like button and you can comment your thoughts. Okay, so in the next video we'll implement this template method. So that's all for this video, guys, and thank you so much, guys, for watching this video. I will see you in the next one.